Let us consider a sample problem with the presence of rolling friction, towing a car. Let us make a statement of the problem. Find the horizontal component of the force able to pull a car of 1,200 kilograms. The coefficient of rolling friction delta is given to be 20 millimeters, and the coefficient of sliding friction is given to be 0.6. The marking of tires is given to be 175, 70 or 15. Assume the pressure of the car's wheels on the roadbed to be uniform. Before we tackle the main problem, let us dwell on the marking of tires. And using the marking, find the radius of a wheel. The number shown first in the marking, 175, is the tire width. The second number, 70, is the sidewall height expressed as a percentage to the tire width. Finally, the number 15 indicates the internal rim diameter of the wheel in inches. The radius is half of the wheel diameter. The diameter is calculated as the sum of the wheel rim diameter, converted into millimeters, plus 2 tire heights. Then the radius is 313 millimeters. Let us build an FBD for the wheel. Active forces which are acting on the wheel are as follows. The gravitational force, which is equal to 1/4 of the car's total weight, because the pressure of all wheels on the roadbed is assumed to be the same. A pulling force, which is equal to 1/4 of the pulling force acting on the whole car. The normal bearing reaction, the force of friction, and the moment of resistance. A wheel is under the action of coplanar force system, so we have 3 equilibrium equations. The sum of projection of all forces of the axis x, the sum of projections of all forces on the axis y, and the sum of moments of all forces with respect to the point O. The axis x and y have their origin in the point O. The axis x extends to the right, and the axis y extends upward. Then the equations have the following form. From the second equation, we find the normal reaction, and from the equation 3, the pulling force is found to be 4 divided by the radius and multiplied by the moment of resistance. According to the Armatron's and Coulomb's laws, the moment of resistance changes from 0 to a maximal value. The maximal value of the moment of resistance is equal to the coefficient of rolling friction times the normal reaction. The coefficient of rolling friction is given to us initially, and the normal reaction we have found from the equilibrium equation. Then, substituting the found value of the pulling force and the maximal value of the moment of resistance, we find the condition for the pulling force. As the moment of resistance arrives at its maximal value, we have a critical value of the pulling force, at which rolling starts under the force action. All the characteristics known, so now we can calculate the critical value of the pulling force. What does this characteristic tell us about? How can we understand it? Is it value great or small? There is such a characteristic as a deadlift strength, standard for man and woman, which is 174 kg forces and 77 kg forces, respectively. Converting the values into kilogram forces, 1N equals 0.102 kilogram forces, we have that our critical pulling force is approximately 77 kilogram forces, which appears quite plausible. If a car has 1,200 kilograms in weight, then an average woman would be able to move it. However, we are not going to stop here, but rather look closer at the friction force. According to the Amaran-Kalam's laws, the friction force ranges from 0 to a maximal value. The maximal value is equal to the coefficient of sliding friction times the normal reaction. Let us calculate the maximal friction force for the conditions over the given problem. In the given problem, under the given conditions, the friction force is going to be 188.05 N, and the maximal friction force with the given sliding friction coefficient will be 1,764 N. It means that the friction force has not reached the maximal value. In other words, rolling is going to be without frictional sliding observed. We can also analyze deeper. Imagine very well that we were pulling a car. There we're rolling along with sliding. At what physical parameters it can happen? Either on ice or on wet or muddy road. In other words, the coefficient is too small. Under the given conditions, the road is smooth, dry, standard asphalt, so the force of friction is quite high. Lowering the friction coefficient, we could attain such a maximal friction force that rolling would be observed along with sliding. The problem has been solved.